Okay, so how do you want to start with that?
Well, similar to this, we could make, I guess, maybe make Pythagorean triangles like this one, almost, but this would be sort of similar
Okay,
to the way we've...
it's all right. So what's a triangle you'd like to start with? Here you can write.
So maybe taking the 1, 1√2 triangle and multiplying the side lengths by 100.
Okay.
Make something like this. And then, I don't know if we could calculate what 100√2 is, but I guess we wouldn't really need to do that because we could just change the 100 to a 99. And
Oh, okay.
yeah, just change this side length to be slightly shorter, which would force this side to be brought in slightly too. So it means this angle here would be just slightly shorter than 45.
Okay. This is a really nice idea. So how then, how do we calculate what that angle is now?
Maybe somehow using the sines and cosines.
Okay.
With this.
You're definitely on the right track. It is gonna, in order to calculate the angle, we're gonna need to figure out the sines and cosines.
But now the problem is this isn't a right triangle anymore, so...
Yeah, it's not a right triangle anymore, so it does make, we can't just do opposite over adjacent or something,
Yeah.
something like that. Do you know what we can do?
No.
Do you?
I'd use the law of cosines here.
Okay.
So
what is the law of cosines?
we're trying to find this angle, theta. I'm gonna write it's right over
I
here.
can zoom out a little bit. Yeah.
Alright.
Not doing great camera
So-
work today.
This says that this side here, 99 squared, equals this side squared plus this side squared minus 2 times 100√2 times 100 times cosine theta. This angle here.
All right.
And then
Do you remember the law of cosines? I'm not sure if you've seen it or not.
I think I've seen it. Yeah.
That's all right. So you identified the problem right away. We need to use sines and cosines, but we don't have a right triangle anymore. But luckily, this thing called the law of cosines comes to our rescue. And why don't we, instead of doing the calculation on the screen, why don't we just turn the camera off? We'll do the calculation, and then we'll just come back and I'll just add it on to this video.
Okay.
okay.
All right. Okay, so we did out the calculation using the law of cosines, and we found that it was 0.775 radians about, which was about 44.427. So does that seem right?
Yeah, it's close to 45 degrees.
Okay, are you surprised it's not closer?
Yes, it seems like just changing from 100 to 99 had a pretty big impact, actually.
Yeah, it shifted about half a degree. Were you surprised that it wasn't closer?
No, that seems about right. I mean, like when you go at his example was like 6 digits, it was only to like 44.999.
Uh-huh.
So I mean, with 2 digits, I don't think it'll be all that accurate.
Okay,
But
interesting.
I guess
All right, well let's try another triangle now.